This is Mr. Martin. This is video number 2 for section 9.3 for Geometry Honors. And at the end of this video, you should understand the relationship between the sides of a 30, 60, 90 and be able to apply those relationships. So here's our 30, 60, 90 triangle. Okay, notice we've got our right angle over here, and then my two acute angles are 30 and 60. And let's review the parts of this triangle again. So we know in a triangle that the shortest side is always going to be opposite the smallest angle, and the converse of that is true. The largest side will be opposite the largest angle. So since this is my 30-degree angle, which is the smallest angle, we know that side RM is going to be the smallest leg. And then the longer leg would be opposite the 60, so across the triangle over there. So that's going to be NM. And that would leave RN as the hypotenuse. How do you know which is the longer leg and which is the shorter leg? Again, the smallest side will be opposite the smallest angle. Okay, and again, the converse of that is true as well. And then our hypotenuse is going to be side RN. Okay, so let's work on the relationship for the three sides in a 30, 60, 90 triangle. It's a little bit more complicated than 45, 45, 90s. So we're going to start with an equilateral triangle, and then we're going to draw an altitude to one side. So remember that the altitude to a side of an equilateral triangle is also the median to that side and the angle bisector. Okay, so here's my equilateral triangle. DFI is an equilateral triangle. I'm not sure what letter that's supposed to be over there. We'll figure that out in a little bit. Okay, but since this is equilateral and I'm drawing in this altitude, altitude makes right angles. Okay, and I also know it's going to be an angle bisector. And I also know it's going to be a median, so it's going to divide this side into two congruent sides. Alright, and so by drawing the altitude to one side of the equilateral triangle, we have created two 30, 60, 90 right triangles. Okay, so let's figure out the relationship of the side. So what we're going to do here is we're going to start out by making the side of the equilateral triangle length 2. And in just a moment you'll see why I do that. So each side is going to be 2, so that's 2, and that's 2. And this side also is going to be 2, but since I drew a median here, I know that this piece here is going to be 1. That's why I made those 2. So now that these are 1 instead of a half. And we've got to figure out what this third side here is. I'm just going to let it be the letter B. Okay, so if the sides are length 2, then what are the lengths of DG and, I guess this is an E, EG? Well, we figured that out already. Those would each be 1. And then let's just look at the left half of the triangle. So we know that this side is going to be 2, and we know this side is going to be 1, and we called this side B. We could call it anything that we want, really. And we're going to use the Pythagorean theorem to find the third side. So here's my right angle. So these are my two legs here. So I know that 1 squared plus b squared is equal to 2 squared. So 1 plus b squared is equal to 4. Subtract 1 from both sides, I get b squared is equal to 3, which means that b is equal to negative square root of 3, because we're going to take the square root of both sides over here, or positive square root of 3, and then we don't need the negative. So now we know that this side here is square root of 3, and we can see that the ratio of the sides shortest to longest is going to be, the shortest side is 1. That's opposite the 30-degree angle, right? Because up here I knew this was 60, and this was 60 because it's equilateral, and this was 60 up here, but that was an angle bisector, so those are each 30. So there's our 30, 60, 90 down here. So the shortest side is going to be opposite the 30, that's 1. The next shortest side is going to be opposite the 60, so that's going to be root 3. And the last side is a ratio of 2. So, and again, a lot of times what we like to do is we like to add a variable to these, and again, I'm just going to use the letter A. You can use whatever letter you want. So if I put a's with these, then the ratio of the sides would be a to a root 3 to 2a. Okay, so this then becomes your important ratio for 30, 60, 90 triangles. And notice that the short leg here, a, is half as much as the hypotenuse. Okay, so the short leg will always be half as much as the hypotenuse. And maybe that'll help you remember that if the short leg is half the hypotenuse, then that other leg just is going to be the root 3 side. So let's take a look at a couple examples here. For this first example, we're going to let df equal 4. So here's df, and that's going to be 4. And what I usually like to do is go through and label my sides with the ratio. So here's my ratio up here. I'm going to label all the sides with these ratios. So here's my 30. So opposite my 30 is going to be my a. And then I know that my hypotenuse is always going to be twice as long, so that's going to be my 2a. And then my last side is my longer leg, so that's going to be a root 3. So every 30, 60, 90, we can always label the sides like this. So now if you notice, over here, the hypotenuse has 2 values. So since we have 2 different values for the same thing, we know that these have to be equal. So that means that 2a has to equal 4, and then I could solve this for a to get that a is 2. Okay, so that means that dg, which is the shorter leg, is going to be 2, and fg, the longer leg, is going to be 2 root 3. Once I figure out what a is, I can just substitute it back in everywhere I need to. Alright, and then when you're labeling the remaining sides, it's always a good idea to use the segment names to name those. Okay, so let's take a look at this triangle. Now I know that DG is 4, so here's my 4 over here. This is my 90, here's my 60, here's my 30. Okay, again, I'm going to label it with my ratio that I figured out up here, a root 3, and 2a. So I'm going to start with the shortest leg, that's going to be a. And then my hypotenuse is always twice as long as the short leg, so that's going to be 2a. And then my longer leg is a root 3. So again, this side has 2 pieces of information, so this is a pretty straightforward case. I know that a has to equal 4. Therefore, I know that my df is going to be twice as long, so that's 2 times 4, or 8. And then my fg is going to be 4 root 3. So if you remember your ratio, and you can put it by the sides of the triangle, you're always going to get one side where you have two things and you can set up an equation. In this case, it's pretty straightforward. A is just equal to 4. Alright, so let's do one more for this video. I'm going to let df be 2x. So I'm going to let this side be 2x. Again, here's my 90, here's my 60, here's my 30. And even though all of my triangles in these examples were oriented the same way, they don't necessarily have to be. So again, I'm going to use a, 2a, and a root 3. So short leg is a. Hypotenuse, it has to be twice as long, so that's 2a. And then my other side is going to be a root 3. Okay, so we want to find the remaining sides, so that would be dg and fg. Alright, and again, here I have two pieces of information, so I can solve that for a. So I have 2a is equal to 2x, and don't get too worried about the fact that we have two different variables in here. So I divide both sides by 2, and I get that a is equal to x. Alright, so we're going to substitute in that x the same way we did before. So that means now that dg is equal to x. Alright, so instead of a number, we just have a variable. And fg is equal to x root 3. Again, just substituting in x for a. And here's my answer for this one. Alright, so to summarize here, in a 30, 60, 90 right triangle, if the shorter leg has a length of x, then the longer leg has a length of, we just figured that out right here in this last example, x root 3. And the hypotenuse has a length of 2x. The ratio of short leg to long leg to hypotenuse for this triangle then is 1 to root 3 to 2. Or again, I like to write this in terms of the letter a, so it would be 1a, or just a, times a root 3 times 2a. And that's what I would use to label my triangles. Alright, so go ahead and work on the practice problems, and if you have any trouble with those, make sure that you ask me. And we will see you in the next video.